Expected value part 2. Action item 1, refining your game or refining my game. I've got a game called Lucky Spin that is already pretty great, but I'm planning to refine it further to make it incredibly user-friendly while ensuring it remains profitable for my casino. What I started with, a wheel with 10 slots numbered 1 to 10, cost $2 to spin. Land on 10, you win $15. That's your $2 back plus $13 profit. Land on 1 to 9, you lose, and I keep your $2. Checking it out. Easy to play totally. Pay $2, spin, hit $10 for $15, or lose on 1 to 9. Simple stuff. Payouts and odds, odd goods. A 1 in 10 chance to win $15 is thrilling. I'll double check the math later to confirm I'm coming out ahead. Is the fee clear? Absolutely. $2 every spin. No room for confusion. Does it favor my casino? I believe so. Wins are uncommon, and I'll be back it up with the expected value calculation next. Refining it. The rules are straightforward, but I'll adjust the payout explanation. If you land on 10, you win a total of $15. If you land on 1 to 9, you lose your $2. This ensures there is no misunderstanding. Nothing else to change. Is a smooth, and that $15 price should attract players in. My final rules: pay $2 to spin, and a 10 slot wheel, or 1 is to 10. Land on 10 gets $15, land on 1 to 9 gets 0, and I keep your $2. Action item 2, computing the theoretical expected value. I'm calculating the expected value to determine if my casino has the advantage. EV represents the average amount of the player wins or loses per spin. A negative expected value means the players lose money over time, and my casino profits in the long run, which is exactly what I'm aiming for. Step 1. Outcomes probabilities. My game rules. A quick recap. Lose if you land to 1 to 9, you pay $2 and get 0. Net is equals to 0 minus $2 is equals to negative $2. Win if you land at 10, you pay $2 and get a $15. Net is equals to $15 minus $2 is equals to $13. Chances. Lose if you land to 1 to 9. 9 out of 10 of slots is equals to 9 over 10 is equals to 0.9. Win. Land 10. 1 out of 10 slots is equals to 1 over 10 is equals to 0.1. Step 2. The expected value formula. Here's the formula. EX is equals to outcome times probability plus outcome 2 times probability 2. Plugging in my numbers, outcome 1 is equals to negative 2 or lose. The probability 1 is equals to 0.9. Outcome 2 is equals to $13. Win. Probability 2 is equals to 0.1. So expected value is equals to negative 2 times 0.9 plus 13 times 0.1. Step 3 to do the math. Losing part. Negative 2 times 0.9 is equals to negative 1.8. Player loses $1.80 on average from losing spins. Winning part is 13 times 0.1 is equals to 1.3. Player gains $1.30 on average from the winning spins. Add them. Negative 1 0.8 plus 1.3 is equals to 0.5. So expected value is a negative 0.5. Step 4, what it means. The expected value is negative 0.50, meaning players loses 50 cents per spin while I gain 50 cents in profit. With a negative expected value, my casino has the edge, as a $13 win isn't enough to outweigh the 9/10 odds of losing $2. So I'm positioned to earn money consistently over time. Action item 3, running the experiment. It's time to put my theory to the test. I'll need at least 3 players spinning multiple times to observe patterns and monitor the balance of my casino. Setup. Rules: $2 per spin, $15 on 10, and 0 on 1 to 9. I'll simulate 3 players, player A, player B, and player C, each doing 20 spins for the combined total of 60 spins. Balance tracking. Begin with 0, increase by $2 for each spin, and deduct $15 for every win. Results. Player A, 20 spins, wins 10, or 2 times is equal to 2 times $15 is equals $30 paid out. Loses 18 times is equals to 18 times $2 is equals to $36 collected. Balance is $36 minus $30 is equals to positive $6. Player B, 20 spins, wins 1 time. 1 times 15 is equals to $15 paid out. Loses 19 times is equals 19 times $2 is equals $38 collected. Balance is positive 6 plus $38 minus negative $15 is equals to $29. Player C, 20 spins, wins 3 times, as 3 times 15 is equals to $45 paid out. Loses 17 times, and 17 times 2 is equals to $34 collected. Balance is $29 plus $29 plus $34 minus $45 equals $18. Final casino balance. After 60 spins, I end up with $18 profit. Action item 4, comparison and discussion. Let's determine how my $18 compares to my expected value prediction and figures out if it aligns up. Expected value prediction. Expected value is equals to negative 0.50 per spins for the player. So I expect positive 0.50 per spin. For 60 spins, 60 times 0.50 is equals to $30 profit. Actual versus expected. I made $18 instead of the expected $30, falling short by nearly $12. Did it match, or did it match? Why or why not? While it's not perfect, I'm still up in the positive, which makes sense since the expected value is negative for players with only 60 spins. Luck can have a big impact. I had 6 wins, or 10%, matching the 1 to 10 odds, but those $15 payouts made a bigger difference in a small sample. A few more or fewer wins could push the total closer to $30. Was the number of spins sufficient to determine the outcome? After 60 spins, I'm earning money, but it's not consistently at 0.50 per spin yet. To achieve a consistent average of and reaching a $30 for every 60 spins would likely around 100 to 200 spins. Nonetheless, the $18 profit confirms that the casino winning vibe. Recap. A game lucky spin is $2 to spin a $10 slot wheel. Land on $10 and win $15. Land on 1 to 9 and I keep your $2. Expected value is equals to negative 2 times 0.9 plus 13 times 0.1 is equals to negative 1.8 plus 1.3 is equals to negative 0.5. Players lose 50 cents per spin while I earn 50 cents. Experiment 3 players completed a total of 60 spins, resulting in an $18 profit. Discussion: I expected $30 but ended at $18. It's close, yet 60 spins aren't sufficient to precise alignment. Additional spins would help even things out.